This video covers section 4.4, solving direct translation, geometry, and uniform motion problems using systems of linear equations. Objective 3, model and solve uniform motion problems. Practice 1. If you travel at an average speed of 45 miles per hour for 3 hours, how far will you travel? If you travel 45 miles every 1 hour, and you want to know how far you get in 3 hours, you multiply by 3 hours, and that's going to end up giving you the distance that you travel. 3 times 45 is 135 miles. And so we call the 45 miles per hour, we call that a rate. The hours, we call that a time. So the formula that we just discovered is the rate times time equals distance. D equals RT or RT equals D. It is this formula that we use for all of our uniform motion problems. If we stay at a speed uniformly of 45 miles per hour, and we do that for 3 hours, we will get 135 miles. So when we get a problem that talks about time and miles and rates, we use distance equals rate times time. We have distance equals rate times time. Suppose that flying 1,200 miles west requires 4 hours and flying east requires 3 hours. So what happens when you fly west and east? There's always wind, either a headwind or a tailwind in this case. And so you have the airspeed of the plane and the effect that the wind resistance had on the plane. So that's a fancy way of saying you'll have the speed that the plane can do by itself, and then you'll have the speed of the wind. So when you fly west, it takes you longer than it does to fly east. And that's because when you fly east, you have the wind pushing you along, so you're going with the wind. Takes you less time, so the wind is helping you. But west, you're going against the wind, so it takes you longer to get home. So we label these as with the wind and against the wind. All right, so the trick to these problems is to recognize that they want to know what the speed is of the plane by itself. Call that X. And they want to know what the speed of the wind is. Call that Y. And so when you go with the wind, as you fly east, whatever you can do by yourself, the wind adds to it. So your new rate with wind is X plus Y. You can go Y miles an hour faster than what you can do without any wind. So the rate with the wind is X plus Y. But when you go back the other way, this time the wind is in your face and it's pushing against you, so that when you go against the wind, your rate is the minus. The wind will take away your speed, some of your speed. And so the rate against the wind is x minus y. That is the major trick to these problems when we go with and against the wind or with the current. Sometimes you have a current in the ocean or in a river. Now we remember that when we went west, which was against the wind, it took us more time, 4 hours. And when we went with the wind, it required 3 hours to go a total distance of 1,200 miles. We went 1,200 miles in both directions. So we use the formula rate times time equals distance. Rate times time equals distance. At this point, we solve this by elimination. But before I do that, I'm going to take these equations and I'm going to clear those threes, the 3, and I'm going to clear the 4. So with the 3 times x plus y equal 1,200, I'm going to divide the left by 3 and the right by 3. And that's going to give me x plus y is 400. 4 times x minus y equals 1,200. I'm going to divide the left by 4 and the right by 4, and then we get x minus y is 300. The reason we did that is because now we can solve this pretty simply by elimination. We have the plus y and the minus y, so we go ahead and add our 2 equations together now because we have the opposite pairs. Adding these 2 equations together gives us x plus x, which is 2x, y plus negative y is 0, and 400 plus 300 is 700. All we have to do now is divide by 2, and we get x is equal to 350. We just found out that the plane can fly by itself 350 miles an hour. By itself with no wind. And then we've got these 2 equations to plug back into to find y. If x plus y is 400, then 350 plus y is 400. And that says that y is equal to 50. And so that means that the wind has a rate of 50 miles an hour. So you can check this by saying when we go with the wind, we were going 350 plus 50, which is 400 miles times 3, which is 1,200. And when we went against the wind, the 50 was taken away from the 350, which gives us 300. But this required us 4 hours because we were going slower to get the same distance. All right, and looking back over this problem, the trick is to let x be the speed of the plane by itself and y be the speed of the wind. With the wind, you go x plus y, and against the wind, you go x minus y. Practice 3 is for you to try. I encourage you to press pause on your video and come back when you're ready to see the solution worked out. Now that you've had a chance to work this out, I'll work this out for you. Let's start by making a table. And at the top of the table, we use distance equals rate times time. When we went with the wind, a plane flew 1,000 miles. That's a distance in 4 hours. If x is the speed of the plane in calm air, rate is another word for speed. And y is the rate of the wind, or speed or rate of wind. When we have our plane go with the wind, its speed that it can do without any wind gets added to the speed of the wind, x plus y. And when we went against the wind, the plane required 5 hours to fly that same exact distance of 1,000 miles. And this time when you go against the wind, the speed of the wind takes from your plane's rate in calm air. So we follow the formula and we take the rate times time. 4 times x plus y equals 1,000, and 5 times x minus y equals 1,000. The easiest way to deal with these problems is to divide the first equation by 4 and get rid of that 4 in front of the x plus y. And that will give us x plus y is 250. If we take the second equation and divide both sides by 5, we'll just have the x minus y equals 200. And now we pay attention to the fact that we have the plus y and the minus y. We want to always remember that that's what you'll get because we're using the plus y and the minus y from the start. And now we can solve by elimination. So we add those two equations together. X plus x is 2x. Y minus y is 0. 250 plus 200 is 450. To solve for x, we divide both sides by 2 and get x is equal to 225. So the plane in calm air is 225 miles per hour. The wind, if we have x plus y, is 250, or x minus y is 200. It doesn't matter which one you use. That says 225 plus y is 250, and y has to be 25 miles an hour. So the rate of the wind is 25 miles an hour. And so again, when we check this, that means that when we go with the wind, we're going 225 plus 25, we're going 250 miles an hour times 4, which is 1,000 miles. And when we go against the wind, we subtract and we get 200 miles an hour for the plane. Times 5 is 1,000 miles. So it all works out. This concludes the video for section 4.4, solving direct translation, geometry, and uniform motion problems using systems of linear equations. Objective 3, model and solve uniform motion problems.